Our planet has 5 oceans: the Pacific, Atlantic, Indian, Southern, and Arctic, not counting Billy Ocean. But it seems there's a 6th one out there too. It's just that you can't see it. Scientists have found evidence of large amounts of water hidden in the transition zone. That's the boundary layer that separates the upper and lower mantle of our planet. That boundary goes hundreds of miles deep down below the surface. Natural diamonds usually form in the mantle, but at depths of up to 155 miles. Some of them are very rare. They may come from deeper depths. That was the case with this fascinating diamond that formed 410 miles below the surface. The gem was big enough for scientists to study it and determine what it was made of. They were surprised when the composition of this very rare diamond showed that it was formed in pretty watery conditions. Because of that, such a diamond wouldn't be worth much in jewelry stores, but it was priceless in the lab. So, could this mean there's an ocean under the surface of our planet? It would definitely get us closer to the idea Jules Verne had about this whole magical secret world inside Earth, including the ocean. But that's not exactly the case. The water is there, true, but it's not like you can enjoy the view watching waves splashing around like on the surface of our planet. The water is actually stored within the minerals. That's why this area is so wet. Let's now move to Africa to keep up with the story, or to be more specific, to a spot called the Afar region. It's part of Ethiopia and a place where 3 tectonic plates meet. Tectonic plates are large pieces of our planet's crust that slowly move. These movements cause earthquakes and produce volcanoes, mountains, deep underwater valleys we call trenches, and so on. And the Afar Valley is where the Arabian, Somali, and Nubian plates meet. Together, they form an intersection in the shape of a Y. Why? Let me tell you. These plates are moving all the time. The Somali plate is moving southeast toward the Australian and Indian plates. The Arabian plate is moving north, getting closer to the Eurasian plate. At some point, it will close the Persian Gulf. This movement of plates has created something we call the Great Rift Valley, considering there are, all these cool rifts. The Aden Ridge to the east, the Red Sea Rift to the west, the Oculus Rift and the East African Rift to the south. But the East African Rift is something we want to focus on, because this one could be the key to this potential 6th ocean, but this time on the surface. A continental rift is a spot where 2 tectonic plates that form a single continent start to separate. Here it's the Somali and Nubian plates. Together, they're parts that make up Africa. If they keep moving in separate directions, this currently continental rift may become what we call an oceanic spreading ridge. In other words, when the plates are far enough apart from each other, there will be an enormous crack between them. This way, magma will freely flow up from beneath them. It'll be cool and eventually start creating a new ocean floor. Africa will be split into 2 parts, and there will be a new ocean flowing between what will turn into 2 mini-continents. Nope, it's not time to get your swim trunks and sunscreen yet. Even if the Somali and Arabian plates do move far enough to form an oceanic spreading ridge, it'll take millions of years before this happens. So I guess it's more interesting to stick to exploring this 6th ocean below the Earth's surface for now. The idea of subsurface oceans goes beyond the borders of our planet. It's possible many moons and planets out there have them too. Our home planet is the only one we know about with consistent bodies of liquid water on the surface, true. In our solar system, we circle around the Sun in something called the habitable zone. The temperature and atmospheric pressure within this zone allow water to remain in liquid form all the time. But a couple of moons in our solar system could also contain significant amounts of water under their surface. Enceladus, one of Saturn's moons, is the first one. Enceladus is a small frozen ball, 7 times smaller in diameter than our moon, but it's the 6th biggest moon of Saturn. Nearly a decade ago, a spacecraft found evidence that there was a large ocean under its surface. It found and sampled water from the eruptions that resembled geysers. A geyser is a rare type of hot spring that erupts and sends jets of steam and water into the air. You know, like Old Faithful in Yellowstone? Well, this water was erupting through fissures in the ice at the south pole of the moon. That means there might be a liquid ocean under the thick layers of ice. The ocean there is almost nothing like ours. The ocean on Earth is relatively shallow, on average 2.2 miles deep, and it covers 3/4 of our planet's surface. It gets colder the closer you come to the seafloor, and is warmer if you stay close to the surface because of the sun's rays. But the subsurface ocean on Enceladus is at least 18 miles deep. It's cooler at the top because that part is near the ice shell, and warmer at the bottom because of the heat coming from the moon's core. But both our ocean and the ocean on Enceladus are salty. Enceladus is one of the few places in our solar system that has liquid water, which makes it an interesting spot to search for signs of life. Another one is Europa, one of Jupiter's moons. Scientists think similar eruptions of water could be happening there. Knowing there are such geysers there tells us these moons have their own source of energy. Maybe the energy that makes the water erupt comes from gravity or radiation. The same energy could keep a large body of liquid water under the ice. It could even support some forms of life. There are thousands of planets beyond our solar system that orbit other stars. Some are even in the habitable zone. Over a quarter of the ones that we know about could have liquid water, but the majority of them probably have oceans under their surface, like Enceladus and Europa. Pluto might be on this list too, since it's possible it hides a liquid ocean under its thick frozen shell. This subsurface ocean likely formed long after the dwarf planet did, after the heat coming from radioactive elements in Pluto's core melted some of its ice. There's also something called water worlds. Those are moons or planets with global oceans that are more common than we thought. I mean, some call Earth a water world too. 71% of its surface is water after all. And when you look at our home planet from space, you mostly get those blue marble pictures. When exploring other planets, especially those outside of our solar system, researchers often go with a policy of follow the water. After all, water is the main element we know that's necessary for supporting life. And when there's a water world that's close to its parent star, scientists assume it must have formed way farther and then moved closer once its orbit shrank. The composition of the planet was set when it was in a colder orbit, or, in other words, when it made a wider circle around its star. We call the process of orbital shrinking a migration, and if water worlds are really that common, it can be proof that migration really happens. Exoplanets are all those planets that orbit around other stars, not our Sun. Some exoplanets may have oceans that are way deeper than any of those in our solar system, hundreds or even thousands of miles deep. Our Mariana Trench is scary, and it's not even 7 miles deep. And those exoplanet oceans are, wow, almost bottomless.
Look, the sea is glowing from within. It's stunning, yet eerie at the same time. White glow covering a huge area of the sea surface is not what you expect to see on a dark night. You look at one of the scariest and mysterious phenomena in the ocean. Let's study it. On January 30th, 1864, the Confederate ship CSS Alabama was sailing southwest along the Horn of Africa when the crew members noticed a mysterious white glowing sea. Captain Raphael Semmes described it as a sickly and unearthly glare of a phantom sea. Although Semmes was a stern and fearless sailor, he was scared by this bright water in the middle of the dark sea. At first, the crew thought they had been sailing over some kind of flooded ridge. They threw a weighted line, which immediately sank to the seabed several hundred feet down. Obviously, the mysterious glow was not a ridge. For several hours, the ship sailed through this eerie glowing sea, and then, suddenly, this bright region ended. The Alabama entered the usual dark waters. Captain Raphael Semmes' description was one of the very first documented accounts of a mysterious and elusive phenomenon called the Milky Sea. In 1851, in the famous book Moby Dick, this phenomenon was described as a sailor's quiet, superstitious fear at the entrance to the midnight sea of milky whiteness. Jules Verne, in his novel 20,000 Leagues Under the Sea, described this phenomenon more scientifically. One of the characters of his book said that the whiteness was caused by the presence of myriads of infusoria, a sort of luminous little worm, gelatinous and colorless. For centuries, people have reported mysterious glowing water at night, and only recently have scientists got closer to solving this mystery. But first, let's be clear. What Captain Raphael Semmes saw was slightly different from that violet-blue glow called bioluminescence. Aristotle wrote about luminous algae and phytoplankton in the 3rd century BCE. He noticed that sometimes the water produced bright blue flashes when he hit the surface of the sea with a baton. In 1492, Christopher Columbus observed unusual flickering of light in the ocean caused by bioluminescent marine worms. As it turned out later, those worms rose to the surface to perform a circular mating dance. In the late 1800s, scientists discovered that bioluminescence is the result of an oxidative reaction inside certain animal and plant cells. You might have seen it at night while walking along the shore. If not, you can watch a video with bioluminescent water on the internet. But milky seas are a slightly different phenomenon. The sea glows white as if it's illuminated by a bright spotlight, and the area of white water can extend for miles. Unlike bioluminescence, milky seas are a rarer and quite elusive phenomenon, which is why it was so difficult for scientists to determine its nature. People didn't come across such glowing waters very often, so many regarded it as legends about mermaids or sea monsters. But in 1985, science got a chance to study this thing in more detail. That year, a U.S. Navy research vessel got into the Milky Sea while sailing near the Arabian Peninsula. There were scientists on board who collected some samples of milky water and conducted a laboratory analysis. And that's what they found out. The water contained bioluminescent bacteria, but what caused them to glow? Scientists suggested that algae colonies first rose to the water's surface. They began to bloom and gradually decompose. Those cells of rotten algae burst and release special substances, lipids. A huge number of bacteria began to feed on lipids and multiply rapidly. The number of bacteria grew in such large numbers that they began to produce a continuous white glow. But where exactly and under what conditions could these milky seas appear? It was necessary to know not only for scientists, but also for authorities. Such a bright spot in the water could reveal the outlines of a submarine and turn it into an easy target for enemies. So scientists continued their research. One of them was atmospheric scientist Stephen Miller. He started studying milky seas in the early 2000s and made a breakthrough in his research. To begin with, he decided to find out if the sensors on space satellites were capable of seeing bioluminescence. Miller started looking for any mention of extensive milky spots on the internet. He came across the Frontier Science portal, where people wrote about strange and unexplained phenomenon around the world. There, he found a report from the British merchant ship SS Lima, which hit the Milky Sea in January 1995 while sailing along the Horn of Africa. This is how the log entry described the event. The bioluminescence appeared to cover the entire sea area from horizon to horizon, and it appeared as though the ship was sailing over a field of snow or gliding over the clouds. After that, Miller collected the images taken by certain satellites over the place where the SS Lima sailed at that time. At first, he didn't notice anything strange, but later he realized that he was looking directly at the Milky Sea. The area of the glowing spot was so large that he had to scale the image down. That's when he saw a spot that looked like a comma. The edges of this spot coincided with the place where the crew of the SS Lima saw the white glow. Miller studied the images of this area taken before, during, and after the encounter, and found out that the Milky Sea rotated counterclockwise to the local ocean currents. But most importantly, Miller now knew that the White Sea could be seen from satellites. In 2011, 2 satellites with more sensitive sensors, capable of seeing in poor light, entered Earth's orbit. They helped Miller and other scientists to find out that Milky Seas appeared most often in the winter and summer in the northwestern Indian Ocean and around Indonesia. Great! Now Miller had the place and time to work with. He analyzed satellite data for the period from 2012 to 2021 and found out that one of the largest Milky Sea incidents occurred in 2019. For 45 nights, a white glow covered 40,000 square meters, which is the approximate area of Kentucky. But even after all these studies, scientists haven't managed to find the exact cause of the white glow. In addition to the idea about the disintegration of algae, researchers have put forward a theory that the glow may be caused by quorum sensing. This is the ability of bacteria to communicate using chemical signals that produce light. Okay, let's say there's some truth to this, but why are they doing this? To find out, let's look at classical blue bioluminescence in other organisms. Some biologists suggest that with the help of the glow, bacteria attract partners for reproduction. Another theory claims that the bright light works as an alarm when dangerous enemies appear in the sea. For example, a colony of phytoplankton meets hungry fish. The organisms turn their glow on to attract larger fish. It's like using evil to fight another evil. There are many theories, but what's the problem with figuring out the exact reason? Even with all the satellite help and studies of Milky Seas, it's quite difficult to get to the right place at the right time. Let's say a white glow the size of a football field appears in the sea. The satellites notice this and send a signal to the research center. Next, a team of scientists boards a vessel and goes directly to the place. The distance to the Milky Sea can be quite big. And by the time they arrive, the glow has already disappeared. In an ideal situation, scientists need to be around the area before, during, and after the glow to get the full picture. Unfortunately, this is not possible at the moment.
Over 1,500 people lost their lives in this part of the ocean, so maybe it's a prudent idea to stay away from it. The spot where RMS Titanic sank remains dangerous. I mean, yeah, there are still huge icebergs out there, but there are even bigger threats lurking beneath the surface. Titanic is sitting about 12,500 feet underwater, nearly 400 miles southeast of Newfoundland. It's been down there for over 100 years. So, over time, the wreck's just been falling apart little by little. The infamous ship is rusting just like any iron or steel structure would be underwater. Chemically, when you mix iron, oxygen, and water, that combo sets off a reaction that creates iron oxide, and that's what leads to corrosion. So, steel plates, beams, all that stuff is getting weaker. Parts of the liner are caving in, like the ceiling in the captain's bathroom and a section of the railing that collapsed not too long ago. But in the case of Titanic, a lot of that corrosion is actually being caused by iron-eating bacteria. When the Titanic sank, it split into 2 big pieces, the bow and the stern, which landed nearly 2,000 feet apart on the ocean floor. And now both pieces are covered in this biofilm, a living blanket of bacteria, marine fungi, and all sorts of other microbes. Over time, microbes feeding on the ship's iron have created these things called rusticles, and they are actually speeding up the wreck's decay. Scientists say the stern is breaking down way faster than the bow, mostly because it took more damage when the ship sank. And now, thanks to all that bacterial activity, the stern could be deteriorating as much as 40 years ahead of the bow. So yeah, microbes have been thriving and flourishing down there. If you are a germaphobe, that probably sounds like a total nightmare. But honestly, it's not that bad. For one, they don't even look gross. These rusticles actually look kind of cool. like ice crystals or tiny diamonds clinging to the wreck. And don't worry, you are not in danger. As long as you keep a safe distance from the wreck, no direct contact, and definitely don't go poking around inside, there really is no risk. Speaking of getting dangerously close, we've got to mention the Titan submersible disaster. You know, the one that catastrophically imploded back in 2023 during a trip to the Titanic wreck. Sadly, all 5 people on board lost their lives. Even though this trip was sold as a tourist adventure, going that deep in the ocean is no joke. It's terrifying, cold, and dark. Sunlight gets absorbed by water and can't reach much farther than about 3,300 feet below the surface. Past that point, the ocean is in total darkness all the time. Titanic lies within a region known as the Midnight Zone for this very reason. The few brave people who have visited the wreck say the descent takes over 2 hours through complete darkness. Then, out of nowhere, the ocean floor just pops into view, lit up by the submersible's lights. The second big challenge is actually finding the wreck. At that depth, navigating is no easy task. When you reach the bottom, you really don't know exactly where you are. You're just kind of fumbling around in the dark, knowing that Titanic is somewhere down there, but you can't see it. However, detailed maps of the Titanic site, made from decades of high-res scans, really do help. As the wreck starts to come into view, they can use those maps to stay on track. Plus, sonar and sensors let the crew notice features and objects even if they're way beyond the sub's tiny light pool. For example, the Titan submersible had a sensor called the Doppler velocity log. This one sent out sound waves to measure how fast the sub is moving and how deep it is, based on its distance from the ocean floor. Still, passengers on previous trips to Titanic in this submersible have said how tough it is to find their way once they reach the ocean floor. And we can't forget about the pressure. The deeper you go in the ocean, the more pressure the water puts on everything. And the pressure is crazy high at the Titanic's wreck site. To put it into perspective, it is about 200 times the pressure inside a car tire. That's why submersibles need super thick walls to handle it. So yeah, the water around Titanic has creepy microbes, pitch-black darkness, and insane pressure. But there is one more thing happening down there, and that's unpredictable currents. You're familiar with them. I mean, when you swim in the sea, you can usually feel the currents pulling you from side to side. But the deep ocean has its own set of underwater currents too. They're not as strong as the ones you feel on the surface, but they can still move massive amounts of water around. These currents can be caused by things like wind, differences in water temperature and salt, and even strange storms down on the ocean floor called benthic storms. They can get intense and stir up the sea bottom. Now, like I mentioned earlier, the Titanic wreck is in 2 big pieces, the front and the back, and researchers have been checking out the seabed of the surrounding area. One part of the wreck is near this cold underwater current called the Western Boundary Undercurrent. It flows south and moves mud and sand along the ocean floor, creating ripples and patterns that show how strong or weak the current is. Most of the time, the currents there aren't very strong. They even found sand ripples near where all the Titanic debris landed, like furniture, coal, and just random stuff from the ship. And those ripples are showing a current flowing from east to west. But inside the main wreck site, things get a little wilder. The water flows more from northwest to southwest, probably because all the huge chunks of the ship are messing with the flow. Around the south side of Titanic's bow, the currents get unpredictable too. They keep switching directions, from northeast to northwest to even southwest. It's like the ocean's just doing its own thing down there. Experts think that, over time, all this shifting water is going to slowly bury Titanic under layers of mud and sand. Little by little, the wreck could just fade away and disappear beneath the ocean floor. Alright, now it's time to get to the obvious issue here: icebergs. Yep, they're still a problem for ships today. In 2023, around 380 icebergs flowed into the busy shipping routes between North America and Europe. That's a problem. You see, the bigger the iceberg, the easier it is to spot and avoid. Smaller ice is a lot harder to detect, though it's no less dangerous. And that's because the most dangerous part is underwater, where no one can see it. Think about the iceberg that sank Titanic. Passengers saw about 100 feet of it above the water, but it's believed that's only 16% of its total size. Experts say the rest, hidden beneath the waves and much larger than what's visible, could stretch down several hundred feet. Now, the good news is that, unlike Titanic's day, we have much more technology now to spot icebergs in time. Modern ships have radar and satellite imagery that can pick up icy threats hiding in the dark. Some vessels even use sonar and thermal imaging to see through fog, helping the crew to spot icebergs above the surface. GPS and AIS pick safer routes, and monitoring centers around the globe send out real-time alerts, like having a personal iceberg spotting assistant. So, yes, it is a massive upgrade from just relying on binoculars. You won't have to worry about icebergs on your next cruise vacation, even if it passes alongside Titanic's route. But just to be extra safe, try not to travel with anyone named Jack or Rose, and never play the violin while on board. Just saying.
Roofs fly off like paper, huge trees are yanked from the ground, power lines snap and leave neighborhoods in the dark. Streets flood like rivers, homes are left in ruins. That's a hurricane passing through. After the wind calms down, the real mess begins. People stranded, no clean water, destroyed roads. Storms have been picking up for like 5,700 years. And the scariest part is that in the last 20 years, there's been a huge spike. But let's start from the very beginning. This is Belize, a small country on the northeastern coast of Central America. And this is the Great Blue Hole, a huge, deep underwater sinkhole about 410 feet deep and approximately 50 miles off the coast of Belize. It formed around 10,000 years ago when the sea levels rose after the last ice age. A team of scientists arrived in Central America to study mud from way down in the Great Blue. They pulled out a long sample of sediment, which is basically layers of stuff that's settled over time. You might ask, so what? How are tropical storms connected with this sediment? Let's see. Tropical cyclones are big, spinning storms that form over warm ocean water. They pull up heat from the sea and blast it into the sky. And yeah, they can be devastatingly destructive, with super strong winds, heavy rain, and floods from big waves. And mud cores like the one the researchers pulled up are actually records of tropical storms. The sample they pulled up was 98 feet long, which made it the longest ever found in that area. Here's how it works. Every year, two thin layers of sediment settle in the hole where the weather is calm. But when a big storm hits, it leaves behind a different, messier layer. So by looking at these layers, scientists could tell how many storms hit that spot over the last 5,700 years. It's like counting tree rings, you know? Anyway, what they found was rather unexpected. It turns out that tropical cyclones had been getting more and more common. The lead researcher said that over the past 6,000 years, there were usually between 4 and 16 tropical storms or hurricanes every 100 years. But just in the last 20 years alone, they found signs of 9 storms in that same little area. That's way more than usual, and it shows how much things are changing. Scientists think there are 2 main reasons why tropical storms have been happening more often. One reason has to do with something called the Intertropical Convergence Zone, or ITCZ. This is an area near the equator where winds from the north and south come together. That spot has low air pressure, lots of moisture, and tons of thunderstorms. Just above it is the part of the Atlantic Ocean where most hurricanes are born. It even has an official name, the Hurricane Main Development Region. Normally, the ITCZ moves north in the summer and south in the winter because of changes in ocean temperatures. But over the past few thousand years, it's slowly been shifting farther and farther south. That's why the area where storms usually start has also moved south. It means storms are now forming and heading toward lower parts of the Atlantic than they used to. The second reason for the recent spike in storms is rising ocean temperatures. Earth has gotten warmer, and the ocean has warmed up too. The warm oceans help make more powerful storms. Such an increase likely means that this part of the world might see a lot more big storms in the future. If things keep going the way they are, scientists think the Caribbean could get hit by as many as 45 tropical storms and hurricanes by the end of this century. That's way more than anything the world has experienced in the last 5,700 years. There are just too many changes in the world that influence the situation. They create the perfect conditions for more storms to form and get really intense really fast. But if you think storms are getting more intense only over the ocean, let me tell you about America. A bunch of really dangerous storms, including tornadoes, dust storms, and wildfires, tore through several states in the Midwest and south of the USA in March 2025. At least 42 people lost their lives, and the scale of the devastation is enormous. What's scary is that most of this destruction didn't happen in the usual Tornado Alley area. Tornado Alley is a nickname for a part of the US where tornadoes happen a lot. It stretches through places like northern Texas, Oklahoma, Kansas, Missouri, parts of Louisiana, Iowa, Nebraska, and even eastern Colorado. But this time, storms hit places like Mississippi, Arkansas, and Alabama. Experts had warned this might happen. At the beginning of 2025, they said that tornadoes could start showing up more often farther east than usual, and that's exactly what's happening. One of their top weather experts said people in the Mississippi and Tennessee valleys should get ready for a rough spring. There are more people living in these areas than in traditional tornado zones, and many of them live in mobile homes or buildings without basements, which puts them at more risk when big storms hit. A tornado is basically a spinning tube of super strong wind that comes down from storm clouds and touches the ground. They can be really dangerous. To figure out how strong a tornado is, scientists use something called the Enhanced Fujita Scale. It goes from EF0, which stands for the weakest tornado, to EF5. Such a tornado is crazy strong, tear your house apart strong. The main question is, why are tornadoes happening more in the east now? In the US, tornado season usually kicks off in March. That's when cold air from Canada bumps into warm, wet air coming up from the Gulf of Mexico. And boom, storms start to form. But this year, things are a bit different. Here's what's going on. There's a big patch of high pressure, basically a chunk of calm, warm air hanging over the southwest. That's keeping things more stable out west, so fewer thunderstorms as well as fewer tornadoes are expected there. So, tornadoes are shifting eastward. Meanwhile, the Gulf of Mexico is super warm this year, and that's helping storms form in the southeastern US. The warm water adds a lot of energy to the atmosphere, which can lead to stronger, more frequent storms in places like Mississippi, Alabama, and Tennessee. Up north, around the Great Lakes and Northeast, it's staying cooler this spring. That means fewer big storms up there, at least for now. Now, let's get back to those devastating March storms. On March 14 and 15, a huge storm system blasted through parts of the central and southern US. This system brought 52 confirmed tornadoes, massive dust storms, and fast-moving wildfires. It all led to almost 1,100 canceled flights. About 150 million people were affected by this natural disaster. Two really strong tornadoes classified as EF4s hit Arkansas. The damage was incredible. One of those tornadoes, which hit a town called Diaz, had winds up to 190 miles per hour. That's insanely fast. For comparison, the average speed of a Formula One car is around 130 to 160 miles per hour. It was the first time in over 25 years that Arkansas got hit by two EF4s on the same day. Experts also recorded wind gusts moving at a speed of over 80 miles per hour in the southern plains. In Texas, dust storms led to fatal car crashes. Wildfires, caused and driven by the strong winds, burned through parts of Texas and Oklahoma. Oklahoma alone had more than 130 fires. So, what's next? Experts think the U.S. could see between 1,300 and 1,450 tornadoes in 2025. That's way more than the usual 1,225. And it's not just about tornadoes. A warmer atmosphere can hold more moisture. That means heavier rains, more flash floods, and even more powerful storms. Basically, the formula is the following. Warmer oceans plus warmer air equals stormy weather, especially in the east and southeast. But even if you don't live in any of these areas, you can't feel completely at ease either. Experts say tornadoes and other natural disasters can happen pretty much anywhere in the U.S. The risk moves around depending on the time of year and the weather.
Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and it's called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, maybe too late for that, but I'll try, the ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please.
Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank one bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But, to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for two main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this: a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia Subduction Zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of two completely different zones, the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the two regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the High Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So, while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
Well, here you are. You're getting into your submarine, feeling a bit anxious. You're going to descend hundreds of feet underwater to explore the ocean floor. So many things can go wrong. Technical issues, insane water pressure, dangerous marine monsters, mysterious eerie sounds. Wait, what? Eerie sounds so deep underwater? Yep, a strange humming noise is coming from the ocean depths. What makes it even creepier is that it only appears during dusk and dawn. This noise might act as a dinner bell, since it's likely to have a connection to massive groups of sea creatures moving up and down through the water to feed. But so far, it's just a theory. Using highly sensitive underwater microphones, researchers recorded a mysterious low-frequency hum at depths of 660 to 3,300 feet. The sound wasn't very loud, just 3 to 6 decibels above the usual ocean background noise. For comparison, when someone is whispering in a quiet library, the sound reaches 30 decibels. The underwater noise also had a puzzling or humming quality. The weirdest thing? Despite their efforts, the researchers couldn't pinpoint a single species responsible for the sound. The noise originates in a region known as the twilight zone of the ocean. This region is dark and doesn't have many nutrients, with no sunlight for photosynthesis. Life here relies on organic debris falling from above, such as deceased organisms or waste material. At the same time, while it may sound barren, the twilight zone is far from empty. A 2015 study estimated that up to 90% of the world's fish could live in this zone, including many undiscovered species. Now, back to the mysterious noise. The researchers believe the sound may be linked to the vertical migration of small marine creatures like fish, shrimp, and squid. These animals move upward toward the surface at sunset to feed on plankton and nutrients, using darkness to avoid predators. At sunrise, they return to the depths to hide. This migration, which is one of the largest animal movements on Earth, involves billions of organisms and occurs daily. Scientists suspect that the strange hum might occur during this migration, as a way for the creatures to communicate or coordinate their movements. It might also serve as a signal to indicate when it's safe for a group to go to the surface and feed. If some animals indeed use the hum to communicate, it could help us understand deep-sea life better. The Twilight Zone has always been considered a quiet environment, but such a discovery hints at complex social behaviors and interactions among its inhabitants. But it's not only the ocean that produces bizarre sounds. Earth is humming non-stop too. Unfortunately, you can't hear this soundtrack. This hum isn't from earthquakes. It's produced by subtle ongoing vibrations in the planet's crust. They're too faint for us to feel and can only be detectable with special equipment. Scientists have long known about this phenomenon called free oscillation and have recorded this persistent hum. Earthquakes are the most noticeable ground movements. According to the U.S. Geological Survey, Earth experiences about 500,000 earthquakes every year. Of those, only 100,000 are strong enough to be felt, and around 100 cause noticeable damage. But in the quieter moments between earthquakes, the planet is still constantly vibrating with smaller, unnoticeable movements. Unlike the sudden jolts of earthquakes, this hum is steady and uniform, and it's a byproduct of microseismic activity. Seismometers, tools used to record ground vibrations, can detect this sound anywhere on land. For years, researchers have been debating the origins of this hum. Some thought it came from ocean waves reaching deep into the seafloor. Others believed it was caused by colliding waves on the ocean's surface. By 2015, scientists had confirmed that both factors contributed to Earth's constant vibration. And although this hum has been recorded on land, now we also have much clearer, more detailed underwater recordings. To study the hum, researchers used spherical seismometers on the seafloor in the Indian Ocean near an island east of Madagascar. Between September 2012 and November 2013, they placed 57 free-fall seismometers across a 772 square mile area. These devices are designed to sink into the ocean floor and record even the faintest vibrations. Over the course of the 11-month study, the team filtered out noise from ocean waves and seafloor currents. They got clear, consistent signals of Earth's hum, with peaks at frequencies between 2.9 and 4.5 MHz, far below the range of human hearing, which starts at 20 Hz. The discovery of Earth's hum from the ocean floor is more than just a scientific curiosity. It gives researchers a new way to study how energy moves through the planet's crust and mantle. In any case, the world around us is filled with weird sounds that sometimes remain unexplained. One of the most intriguing examples is the bloop, an incredibly loud underwater sound recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The sound lasted about a minute and began as a low rumble, which then increased in frequency. It was so loud that underwater microphones detected it across an astonishing 3,000 miles. Initially, some experts thought it was the call of a massive unknown sea creature. However, NOAA later determined that the source likely had been the calving of icebergs, when giant pieces of Antarctic glaciers had been breaking off and crashing into the sea. The sound, known as Julia, a strange cooing noise, could have been produced by an iceberg scraping along the ocean floor. Another sound, dubbed train, due to its resemblance to the sound of train wheels on a track, likely originated in Antarctica's Ross Sea. Then there is upsweep, a recurring seasonal scratchy noise detected in the Pacific Ocean since 1991. Despite years of research, its exact cause remains unclear. The underwater world also has bizarre sounds that can be described as choirs of fish. Scientists studying marine life off the coast of Port Hedland in Western Australia discovered that many fish species sing in synchronized choruses at dawn and dusk, much like birds. Over 18 months, researchers recorded tons of sounds, including foghorn-like calls from black jewelfish and rhythmic ba-ba-ba sounds from batfish. These fish songs, which often involve repetitive calls that overlap in large groups, are especially important for breeding, feeding, and territorial behavior. Deeper in the ocean, NOAA researchers also explored the sounds of the Challenger Deep, the deepest part of the Mariana Trench. They used a titanium-encased microphone that managed to survive the crushing pressure, over 1,000 times the atmospheric pressure at sea level. Over 23 days, the recorder captured loads of noises, from the haunting songs of whales to the rumble of distant earthquakes. Now, we've already figured out that the ocean is filled with strange sounds, but you can also hear weird noises above ground. One of the most puzzling is the hum, a low-pitched noise reported by people in specific areas, such as Taos, New Mexico, or Bristol, England. The sound is often described as a faint engine-like drone, and its source remains a mystery. Some researchers think it might be a psychological phenomenon, where people focus on subtle background sounds they might otherwise ignore. In any case, no definitive answer has been found yet. Geological formations can sing too. Utah's Rainbow Bridge, a massive 300-foot-high sandstone arch, vibrates like a guitar string when exposed to sounds, distant earthquakes, or waves near Lake Powell. Scientists have studied its frequencies to understand how such vibrations could affect the bridge's stability over time. Interestingly, visitors to the Rainbow Bridge have reported hearing faint humming sounds too. The skies also have their own eerie noises. For centuries, people in polar regions have described faint sizzling, popping, and cracking sounds, accompanying auroras. A Finnish researcher made the first known recordings of these sounds and traced their origin to electrical discharges in the lower atmosphere, about 230 feet above the ground. These charges, caused by magnetic storms fueling auroras, produce faint sounds during calm and clear nights. Other natural phenomena, such as icebergs grinding against the seafloor or volcanic activity on the ocean floor, produce groans, rumbles, and crackling sounds that scientists study to learn about glacial movements and underwater geological activity. I myself produced many unusual sounds and rumbles, but, that's a subject for another video, or my next annual review.
In some regions of the Pacific Ocean, ships sink very easily, which is why it is feared by many sailors. Although there are many routes in that area, there are some that few dare to risk because crossing them can mean facing extremely dangerous forces of nature. If you need to travel from Asia to America by ship, the most obvious route would be the shortest and quickest. That is, a nearly straight line under the North Pacific Ocean. But instead, it might be better to avoid crossing this place and opt for longer and more expensive but much safer routes. There is not one, but several reasons. The Pacific is home to some of the most dangerous waters in the world. When we open a world map, we usually see that the Pacific Ocean is kinda divided, which prevents us from realizing how big it is. But in reality, this giant covers almost a third of Earth's surface. It's about 10 times larger than the smallest ocean in the world, the Arctic Ocean. In other words, when crossing it, the chances of being cut off from any landmass are very high. And in cases of emergencies, mechanical failures, or even storms, help might take days or even weeks to arrive. This significantly increases the risk of serious accidents, the possibility of cargo loss, and, in more serious cases, something even worse. Now think about it. A ship journey from Santos, Brazil to Cape Town, South Africa covers a little more than 3,400 miles. To get from Callao, Peru to Shanghai, China, you need to travel around 10,000 miles. Another major problem that prevents sailors from crossing the Pacific is storm systems, whose name already indicates what they contain: unpredictable and therefore dangerous storms. In addition, near the equator, there is a chain of winds called trade winds that directly influence the climate in the tropical region and occasionally cause rain. Trade winds are strong and constant winds that act like a whirlwind that rotates without stopping. And although they are extremely important for nature, as they spread moisture through forests and even influence the formation of deserts, they pose a problem. Their intensity changes depending on the season. In winter, for example, they can be much stronger. And since these winds are responsible for moving the ocean waters, they also create strong sea currents that could make the journey much more dangerous. In 2015, researchers came across a series of extremely strong winter trade winds that caused a surge of short but intense waves in the Pacific Ocean. They observed that those waves began to hit the ship with constant force, as if they were repeatedly punching it. As a result, the hull structure was completely twisted and deformed. And in the end, they confirmed what they had already known. Those waves, caused by winter trade winds, could be a real threat to vessels. And by the way, do you remember that help in the middle of the Pacific can take a considerable amount of time to arrive? So, now there is much more than one reason behind the hostility of the winds. Such a large ocean doesn't have many geographical barriers, such as mountains or large islands. It means that there are no land structures around it that could hold back or slow down the winds and currents. So the trade winds and ocean currents have complete freedom to gain strength and speed. This explains why the Pacific is the scene of powerful storms and giant waves. This is different, for example, from the North Atlantic, where North America, Europe, and Africa help to contain and redirect the atmospheric and maritime systems. It is now very common for scientists to see the bottom of the Pacific Ocean as a giant jigsaw puzzle because it's literally full of moving pieces. It's home to the largest number of tectonic plates on the planet, and one of them, the Pacific Plate, is the largest maritime plate that science has ever identified. This particularity makes the region extremely unstable to earthquakes and volcanic eruptions. Even though the ocean may seem calm at first glance due to its geology, things can change very quickly. This makes it unpredictable and treacherous, For example, in 2022, the cargo ship 1 Apis was crossing the ocean, 1,600 miles northwest of Hawaii, when it was caught in a torrential storm. As a result, more than 1,800 containers were damaged, falling to the bottom of the sea. Hundreds more collapsed on the deck, turning into a real-life steel domino due to the force of the wind. The captain managed to steer the ship to Japan. The journey lasted about a week, and it was only when they got there that they understood the extent of the loss. But it wasn't just the 1 Apis. The following year, the ship Maersk Essen lost about 750 containers, while the Maersk Eindhoven lost more than 260. In both cases, the routes were bound for Asia. These three alone have already accounted for much more than the global annual average of containers lost at sea, which is about 1,382 per year. And the most curious thing is that these events happened in winter. Speaking of winter, it was in the winter of 2020 that the Pacific made history. Scientists recorded a 58-foot-high wave in the ocean, which is equivalent to the height of a 5 or even 6-story building. In general, a wave is considered giant or extreme when it's more than twice the height of the others around it. This one, however, was almost 3 times bigger than the rest. Now, it's important to remember that despite being rare and scary, these waves are not a tsunami, as they're caused by wind. Tsunamis, on the other hand, usually occur after underwater earthquakes or volcanic eruptions. Another big monster of the Pacific are typhoons, and the 2024 typhoon season confirmed this. One of the highlights was Hurricane Christy. It did not touch the crust, meaning it did not cause direct damage, but we cannot underestimate it. Christy reached Category 5 on the Saffir-Simpson scale, which is the maximum level. A hurricane of this degree is considered catastrophic, so it's no wonder that it was powerful enough to generate huge waves and extremely dangerous rip currents. In addition to this, there was also Super Typhoon Yagi, which hit the Asian continent with such force that it gained the reputation of the most powerful in the last 70 years. When it arrived in Vietnam, it caused around $1.6 billion in damage, destroyed infrastructure in several cities, and left a trail of victims wherever it went. As if that weren't enough, the Pacific is also home to one of the most unstable regions on the planet, the famous Pacific Ring of Fire. It's a huge, crack-shaped area that's home to intense volcanic and seismic activity. It's the most tectonically active place in the world, as the plates of the Earth's crust are constantly moving there. They move apart and collide, or grind against each other, which causes the region to experience earthquakes and volcanic eruptions all the time. Seismographs record some type of tremor there every 5 minutes. This dangerous region is responsible for about 90% of the planet's earthquakes. So, 9 out of 10 tremors occur within this ring, which stretches across the northern Pacific. And the worst part is that it doesn't just affect North America or Asia. In 2023, tremors linked to the Ring of Fire were felt in several Latin American countries, such as Argentina, Chile, Ecuador, and Peru. There was a trail of destruction, and the lives of around 15 people were lost. There's no shortage of reasons for ships to avoid the shortest route across the Pacific and opt for longer routes. As the popular saying goes, prevention is better than cure.
It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. Scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nader crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high, almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nader crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years, because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nader asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? Every single building would have been destroyed, and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground, and still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event, this time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA is keeping an eye on. It's called Bennu, and it's about the same size as the Nader impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700, but still, it's a reminder that Earth is always in the cosmic firing line.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, These devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke two seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean's surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, The effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh? Hey, don't freak out. Those red waters you see aren't blood oceans. It's just a natural occurrence called the red tide. Red tides often happen in Florida, especially in the West Florida shelf, and they can stick around for weeks or even months. They're basically caused by an increase in algae levels, hence the color. Those algae produce toxins that can be harmful to marine life. They can also be bad news for us humans, causing symptoms like upset stomach and urgent bathroom trips, if you're picking up what I'm putting down. Volcanoes are super scary, but there's nothing scarier than getting taken out by a pyroclastic flow. These fiery flows move crazy fast and reach insane temperatures, like hotter than your oven on a pizza night. They're like a fireworks show of volcanic eruptions filled with ash, lava, and hot gas, speeding down mountains at 50 miles per hour. Some researchers claim they might even hit speeds of 450 miles per hour, almost as fast as a passenger jet. If you're unlucky enough to be in the path of a flow, you're in big trouble. The heat alone can turn you into a human barbecue, even if you try to hide in a building. The air around the flow can reach temperatures high enough to fry your insides, burn your clothes off, and leave metal melted into your skin, which almost sounds like a Marvel origin story. However, a lot of people have met their end because of these flows. But there's one crazy story about a guy named Luger Silbaris, still sounding like an origin story. So on the 7th of May, 1902, there was a major eruption on the island of Martinique. The night before, Silbaris had gotten into trouble and ended up in jail. Maybe this is a villain origin story. He'd been locked in a sturdy cell facing away from the volcano. The next morning, Mount Pella unexpectedly erupted, destroying St. Pierre within minutes. The flows wiped out around 30,000 people, but Silbaris survived in his cell and became known as the guy who lived through doomsday. The rescue team found him 4 days later. By the way, the cell still stands today. I hope somebody tested him for superpowers. Back on August 21st, 1986, a guy stumbled upon some animals showing no signs of life on his way to Nios village in Cameroon. To his shock, he later found out that everyone in the village had mysteriously passed away. The same thing happened at Lake Manaun in 1984. Turns out, those tragic incidents were caused by something called limnic eruptions, which are pretty rare disasters where carbon dioxide suddenly bursts out of lake waters, creating a hazardous gas cloud. These type of eruptions usually happen in lakes with high levels of CO2, which can be caused by things like volcanic gases and high pressure. Any little change in temperature or pressure can set off an eruption. So, experts have started looking into ways to safely release CO2 from lakes like Manaus and Nyos in order to lower the risk of more disasters in the future. In March 2024, a video captured a terrifying moment of a woman disappearing into a sinkhole while browsing through a Chinese department store. Guess she got more than she bargained for. Ha ha ha. Moving on. The scene unfolded as the floor beneath her gave way, sending her plummeting into the abyss. In the midst of the chaos, another customer frantically ran away before returning to check on the woman who had fallen. Their quick thinking and the swift response of emergency crews and firefighters saved the day, resulting in only minor injuries for both women. I'm glad that lady checked on her because I would be gone. An Anvil cloud is basically a big cloud made of ice particles that forms at the top of really tall thunderstorms, or those huge cumulonimbus clouds. The flat top shape is caused by the air rising in the storm and spreading out when it hits the stratosphere. That's why it's called an anvil. It looks like the tool metalworkers use. Duh. The air from the Anvil cloud is cooler than the stratosphere air, which keeps it from going any higher. You can spot Anvil clouds from really far away, sometimes over 100 miles. Often you might see streaks of snow coming from the edge of the cloud known as virga. The snow disappears before hitting the ground because of the dry air. If you notice clouds poking through the flat top or bubbling up, it's an overshooting top, a sign of a super strong storm. Anvils are known for producing dangerous lightning. Normally, lightning comes from the bottom of a storm, but anvil clouds can produce really powerful lightning from the top. This lightning can strike out of nowhere, even from up to 30 miles away. So keep an eye on those anvil clouds if you see one forming nearby. Lahars are no joke. They're basically fast-moving, super dangerous streams of rock, ash, and water that come down the slopes of volcanoes. It's important for everyone to be aware of them. Scientists, policymakers, and even us regular folks. By understanding how lahars work and their potential impact, we can try to stay safe when volcanoes start acting up. Saving lives during natural disasters is the name of the game. There are two main types of lahars: debris lahars and mudflow lahars. Debris lahars are full of solid stuff like rocks and ash, while mudflow lahars are more waterlogged and sludgy. Lahars can be triggered by the rapid melting of snow or ice, heavy rain falling on loose volcanic material, or even a crater-like eruption. The volcano's characteristics and presence of water are key factors in how lahars form and move downhill. When lahars come barreling down mountains at speeds of up to 120 miles per hour, carrying loads of debris, it's a recipe for disaster. Unless you have a surfboard, but I doubt you'll have a surfboard on a volcano. Just saying. Also, it won't work. Going to the beach for a sunny vacation is the best. There's nothing like basking in the sun, feeling sand between your toes, and hearing waves crash against the shore. But even though it's all relaxing and picture perfect, always keep an eye on the water and never turn your back on the ocean. You may know about rip currents and tides, but have you ever heard of square waves? It's a real thing, and it can be pretty scary. Square waves, also known as cross seas, happen when two swells meet, forming a unique square pattern that looks like a checkerboard. They can be found along coastal areas, and while they are rare, they can create waves up to 10 feet high and make it tough for boats and swimmers to maneuver. If you find yourself in the water with square waves, you might feel like you're fighting against two different currents. The best thing to do is to not go too far out to begin with, and get out of the water as soon as the waves become too strong. Square waves are more dangerous for boats and ships, so it's best to stick to the shallow waters and stay safe. Whirlpools and maelstroms are powerful natural forces that have scared sailors for years. They happen when certain weather and current conditions come together just right. Most of them are safe if you stay away, but let's see what they really are and how they form. A whirlpool is basically water that starts spinning when two currents meet, or one current hits something solid like a wall. They can be big or small, depending on the speed of the water and waves. Most aren't dangerous, but there are also maelstroms, which are large, forceful, and violent whirlpools, caused by ocean tides and narrow straits. Tidal currents in places like Norway's Saltstraumen and Mockstraumen can create massive whirlpools. Scotland's Corryvreckan whirlpool is one of the world's largest. Other examples of whirlpools can be found in Japan, Canada, and New Zealand. Are they portals? They're definitely not portals. Researchers have recently looked into ancient underwater volcanic eruptions and how they affected Earth's climate. They studied materials from Bronze Age eruptions to learn more about their scale, dangers, and impact on climate. For example, one eruption about 3,600 years ago in the Aegean Sea caused chaos in Santorini. The study focused on this event to understand its importance. By analyzing volcanic deposits, the researchers gained insights into how future eruptions could affect climate. They discovered that sediment waves from shallow underwater eruptions could lead to tsunamis and impact the ocean floor. These findings help us understand how underwater volcanic eruptions relate to the marine environment, which can help us predict climate changes in the future. Many terrifying animals live deep beyond the waves, like this vampire squid living 3,000 feet below the surface in almost complete darkness. This animal has a cloak, like a vampire's. That's why it's called the vampire squid. Deep down at the bottom, it can't use ink to defend itself. So this animal has developed an unusual tactic. It glows slightly to scare away predators. If this tactic fails, the vampire squid can turn its body inside out, revealing tiny spikes. When you translate its scientific name, Vampiroteuthis infernalis, it literally means vampire squid from the nether. Despite its terrifying looks, it's a harmless ocean animal. This previous creature was not from space, but this object definitely is. Before Elon Musk found a way to reuse rockets, NASA would simply drop old ones after launching astronauts into space, most of the time in the ocean or deserts. In 2012, Jeff Bezos launched a mission to find the Apollo 11 rocket. They found it by using sonar, but it was in terrible condition. It was sitting on the bottom of the ocean, not far from the predicted site. They were able to rescue the engine and reconstruct two of them. The most famous lost city is Atlantis, but sadly, we still haven't discovered it. However, Heraklion was also just a myth until one British pilot saw something that looked like a city while flying over the Mediterranean Sea. He reported it, and 60 years later, a group of divers went there. They were shocked when they found an entire city underwater. It was loaded with artifacts that could tell us a lot about the history of the place. Now, it's one of the best underwater archaeological sites in the world. It's believed that the rising sea caused the whole city to go underwater. The Titanic sank in 1912. The wreck was claimed to be officially discovered 74 years later. In reality, though, a fisherman found the Titanic 8 years earlier while fishing in the Atlantic Ocean. He was pulling out his net when he spotted a head stuck in it. Luckily, it was just a doll's head. Years later, after the fisher had passed away, his son sold the doll to a doll collector. She did a lot of digging and research on every person who had a porcelain toy on the Titanic. She found the owner of the doll. Ava Hart was on the Titanic and had a doll with her. Ava survived the catastrophe by a miracle, but her toy didn't. Hart even wrote about the doll in her journal, and every detail matched the toy found by the fisherman. The tripod fish lives deep in the abyssal zone, around 20,000 feet below the surface. It's adapted to such immense depths and uses its tripod fins to stay still on the bottom. This creature doesn't have big eyes, but even if it did, these eyes would be useless in the darkness. Instead, The tripod fish uses its fins like antennas to detect any movement in the water. This creature doesn't have much luck when it comes to its love life, so it had to develop unique tactics to reproduce. One fish can be both male and female. The next bizarre creature is the lizardfish. It has tons of razor-sharp teeth, a huge mouth, and really big eyes, which it uses for hunting. All this makes the animal look freaky. The lizardfish lives at depths of around 11,000 feet in the midnight zone, where there is zero light. This freak of nature basically eats everything it can fit inside its mouth, from small fish to other lizardfish. On the other hand, when they see other reptile fish, they probably fall in love instead, because finding mates at those depths is not an easy task. Like the tripod fish, the lizardfish can be both male and female at the same time. When you think of a river, you usually picture it on land. Still, nature is quite unpredictable, and it created a river flowing under the ocean in California. It's running at a depth of around 2 miles. This river has everything that an ordinary river has: sunken logs, trees, and rocks. And despite its uniqueness, it's not the only one in the world. There are also others in the Amazon and Greenland. A terrifying creature was discovered near Angola's coast by a remote operating vehicle. It looks like it doesn't have a head or a body. It was sitting at a depth of around 4,350 feet below the surface. After doing research, scientists concluded it wasn't anything from a sci-fi movie. It was just a cluster of siphonophores stuck together. In 2015, some random guy was diving in Caesarea, and something shiny caught his eye. He reached out, grabbed it, and realized it was a gold coin. After that, he examined the bottom and found out that there were many more. He reported the incident to the local authorities, and they concluded that he had found Arabic treasure. The coins were made of solid 24-karat gold and were a few thousand years old, but due to the perfect salinity and temperature, they looked brand new. The coins belonged to a ship carrying cargo. It was caught up in a storm and unfortunately sank. One of the weirdest things ever discovered was found in the Baltic Sea. It's an anomaly that looks as if it was created by a different civilization. It was discovered by Swedish researchers, and they basically had no idea what it was. They had to ask tons of other scientists for their opinions. When you look at this formation from above, it's 200 feet long and looks exactly like a fallen spaceship. It's hard to believe that it's a natural formation, but spoiler alert, it's totally made by nature because the Baltic Sea has gone through many erosions throughout history. Most likely, the bizarre formation is the result of these processes. A group of divers in Madagascar were shocked when they found this 7-foot monstrosity of a knife on the seafloor. The speculation started immediately, and many said that the knife was from some giants that had fought megalodons and lived on Earth thousands and thousands of years ago. That could make a nice story, but the knife is most likely a movie prop that was lost at sea. One of the ocean's most bizarre animals is the frilled shark. It's believed that this fish is the reason for all those sea serpent stories that sea explorers of the past wrote about. These animals live pretty deep in the ocean, but sometimes they can be seen in shallow waters. It's super rare, but possible. The frilled shark has a big mouth sporting around 300 teeth. It also has a long body that looks like a lizard's, and it is truly a unique species of shark. Its prey can be half of its size because this shark's stomach is like that of a snake, and it can swallow huge fish or crustaceans. Spotting a few worms in your garden is no big deal, but after seeing a 26-foot-long one in the ocean, you will make your wetsuit a little wetter. This worm is super rare, and it's completely harmless to humans. It's actually not a giant worm. It's a cluster of zooids that are stuck together in a worm-shaped formation. They usually only eat plankton, bacteria, and other tiny things that can be found in the ocean. Probably the scariest thing in the ocean that is 100% real is the Magna Pinna, which can be found at crazy depths of 20,000 feet below the surface. This monster looks like an underwater Slender Man, but it's just a squid with really long tentacles that can reach a terrifying size of 8 feet. This guy has only been seen a few times, and basically, we don't know much about this creature so far. If you've ever driven over the Rocky Mountains, you've probably seen road signs for the Continental Divide, the backbone of North America. All watersheds to the west of it run into the Pacific Ocean, and everything on its eastern slope goes straight into the Atlantic. There's just one creek in Wyoming that couldn't choose one side and drains into both oceans at the same time. Two Ocean Creek begins its journey high up in the Teton Range. The snow-capped peaks provide the perfect backdrop as the creek starts its descent, winding its way through alpine meadows and dense forests. As the creek continues its course, it gets to the Two Ocean Pass. This is the geographical crossroads where the creek splits into two branches, the Atlantic Creek and Pacific Creek. The Pacific Creek goes westward and becomes part of the larger Snake River watershed, bringing its waters to the Snake River, which eventually merges with the Columbia River and, finally, reaches the Pacific Ocean. The Atlantic Creek heads eastward and flows into the Yellowstone, Missouri, and Mississippi rivers, and eventually empties into the Gulf of Mexico. If you connect the two creeks' watersheds on a map, you'll get a single blue line between Oregon and Louisiana. Explorers struggling to find the Northwest Passage between the two oceans never knew they could have used the creek. They would just have to use really tiny boats. Some scientists believe that cutthroat trout had better luck in that way. They managed to migrate from the Snake River to Yellowstone River, most likely using the Two Ocean Creek. Technically, fish can travel over 6,000 miles to cover the whole distance from sea to shining sea in fresh water. The creek could be just perfect for that journey. There are hiking trails in Grand Teton National Park that lead to Two Ocean Pass. If you feel adventurous enough, you can stand at the literal crossroads of the continent and see the beginning of two aquatic journeys. Lonar Lake in India popped up literally out of nowhere around 52,000 years ago. Newer data says it could be much older, probably over 500,000 years. At first, scientists were sure that the lake was in an ancient crater of a long-extinct volcano. But then, geologists made a detailed analysis of the soil and water and found out that Lonar Lake has a space origin. The minerals found in its soil are similar to those found in moon rocks brought to Earth during the Apollo program. The lake is an impact crater left by a huge meteorite, which was almost 6 times heavier than the Empire State Building. The impact was so strong that the volcanic rock melted and turned into glass. In 2020, the lake, which was already unusual enough, suddenly turned pink. And it wasn't a part of an early Barbie movie marketing campaign. The detailed analysis showed that the water contained an increased level of unique microbes. They accumulate on the surface and emit some pink pigment. After a while, the microbes settled to the bottom and the lake became transparent again. Flamingos that got their food from the lake also got to taste some of the microbes and became an even brighter shade of pink than usual. One of the most famous sights of Yellowstone National Park is the Grand Prismatic Spring. It's one of the largest springs in the world, and it's inspired people who have seen it since at least the 19th century. Back then, a group of trappers mentioned an indigo blue lake boiling like a huge cauldron. Decades later, expeditions came to the spring to study it better and explain its unusual appearance. But because the spring at its widest point is longer than an American football field, they had to build a special vessel and travel far from the shore. The scientists traveling in the boat never wore life vests. They knew those would be useless if the boat tipped over. The water in the middle of the spring is of near boiling temperature, and those vibrant colors are the result of extreme organisms living in the hot water. The temperature changes as you travel away from the center. Different species that don't mind the heat have settled in different parts of the pool, giving it its famous diverse pigments. Back in the early 20th century, someone got the interesting idea to try to irrigate a part of Nevada's Black Rock Desert. They drilled a well and found lots of water, but it was near boiling temperature. The water was clearly not good for agriculture, so the human-made geyser was left abandoned. Over the decades, it slowly turned into an impressive cone of calcium carbonate deposits. Then, in 1964, a geothermal energy company drilled another well close to the first one. The water they had found was of the same temperature. This time, it wasn't hot enough for their needs to produce energy, so they decided to cap the well and leave. But water managed to get up and out, and it completely dried up the first geyser. The second one, which got the name Fly Geyser, is still flowing burning hot water rich in minerals. The cone is multicolored and looks like it's not from this planet, thanks to the algae living in it, which love the heat. Every summer, Caño Cristales in Colombia turns into a liquid rainbow, or the River of Five Colors. At this time, and until the end of fall, the conditions are just right for the riverbed to turn bright red, yellow, green, blue, and black. We owe this beauty to certain aquatic plants growing in the river, a special type of riverweed. During the wet season, the river moves fast and the sun cannot get to these plants. During the dry season, there isn't enough water to feed them, so the time in between the seasons has the perfect conditions for this colorful show. It doesn't happen anywhere else in the world. At some point, the number of tourists who wanted to see it became so huge that scientists got concerned it could be bad for this hotspot of biodiversity. The area is home to rare species of animals, birds, and plants. Now, there are ecotourism trails and strict opening hours. In August 2014, a man in Tunisia was going back home from the north after doing his business. It was a hot summer evening, and he was dreaming about water, when suddenly, it popped up right in front of him. There was a whole lake in the middle of the desert, and the man was pretty sure it hadn't been there several days before. The new body of water got the nickname Mysterious Lake, and actually became a great mystery. Hundreds of people came here to swim in the clear, cool water. The lake became a popular place, but a few days later, the water turned dark green. The locals didn't care about this and continued to bathe in the lake. But when scientists and geologists arrived at the place, they announced that the water was dangerous to swim in. The lake was stagnating. It didn't refresh itself from underground streams, and the rains didn't feed it either. That's why the water became moldy and dirty. The lake contained algae and a lot of harmful bacteria dangerous to the human body. Scientists also found out that the land in this region had phosphate deposits. This substance can decay. But even that didn't stop people from bathing in the lake in the middle of the desert. How it got there remains a mystery. Some experts think that heavy rains have filled a hole in the ground with water. Another, more popular theory says that an earthquake had formed the lake. The seismic activity must have torn the Earth's crust above the water table, and then underground springs had filled the crevice. So, in theory, the lake could drain back out one day, just as suddenly as it had appeared.
Deep under the Indian Ocean, there's a giant patch where gravity doesn't work like on the rest of the planet. I mean, the gravitational pull works constantly, but Earth is not a regular sphere. Its surface is not smooth. It's covered with lumps and bumps like a potato, because our planet is not the same everywhere inside. Some parts are denser than others. Let's say you could pour water across Earth's surface. The shape this water would make is called a geoid, and it's like that because of the differences in materials inside the planet. That's why gravity isn't the same everywhere, and down there in the dark depths of the Indian Ocean, it's weaker than usual. That spot is something we consider a giant gravity hole that stretches more than 1 million square miles in size. It's roughly where the ocean floor sinks down in a giant depression. Scientists used ships and satellites to figure out this mystery. They realized the water level near India was lower because of this weak gravity spot. They're still not sure what made gravity become so weak in that area. But two Indian researchers realized everyone was trying to understand this, considering what that area looked like in the present. So they decided to go to the past. They used computers to make models of a virtual Earth and figured out that the answer could lie over 620 miles under the surface. That's where a part of an old ocean sank 30 million years ago, causing a hot melted rock to move around. And this mixture might have made gravity weak in that area. It's a really interesting idea, but it's still not the final answer. In 2018, a team of scientists from India went to the Indian Ocean with special machines to listen to the ground rumbling, similar to when you hear thunder. They found out there were hot streams of melted rock coming up from deep inside Earth. Could they be part of the reason why the gravity is weak there? We'll need more information to understand the issue better, maybe even go back further into the past. For instance, about 140 million years back, the land was all connected as a big piece called Gondwana. But then, India started moving away from it. While India was moving, an old ocean floor called the Tethys Sea sank into Earth's insides. These two scientists from India kept trying to solve the case, using computers to pretend to be going back in time. They checked how the land moved, as well as the mantle, which is basically a thick layer of hot, solid rock. The duo found out that a long time ago, there were hot, light rocks rising from deep inside Earth. These rocks created a spot where gravity was weak. This spot was like a big dent in the ocean floor. The more these rocks rose, the deeper the dent became. The first of these rising rocks popped out around 20 million years ago to the south of the weird gravity dent. As these rocks moved and went under the land, the dent got bigger and stronger. The two scientists think these rocks were pushed up by the sinking old ocean floor, like bubbles. This process disturbed something called the African blob. You gotta see this. Deep inside our planet, there are two very big blobs, like giant pieces of rock, as large as continents. One is under Africa, and the other is under the Pacific Ocean. These blobs have roots that start almost halfway, 1,800 miles, toward the center of Earth. And they're probably the place where columns of hot rock rise up from way down below. When these hot rock columns reach the surface, big volcanic eruptions happen. And we're talking about some really massive ones that might have even played a role in erasing dinosaurs from the face of the Earth a long time ago. So, we don't want these giant blobs to be disturbed. Anyway, not all scientists agree with the theory about why gravity doesn't do its job in this particular spot in the Indian Ocean, saying they need more proof to be sure about these rising rocks. The real answer might come from listening to Earth's rumbling. Plus, who knows if this gravity hole will stay there forever or move away. It depends on how Earth's mass will shift around. To see some changes might take a very, very long time, maybe even hundreds of millions of years. That's not the only region where gravity works in mysterious ways. Or at least, that's what it feels like when you see certain things around the world. Like, what if you saw rocks that don't sink, but can float on water for a very long time? They can even travel around for thousands of miles until they finally find a spot where they sink. Scientists figured out how this worked by using special X-rays to check the insides of these rocks. And these unusual rocks turned out to be very light and full of tiny holes. Researchers used wax to cover pieces of these rocks and went with a special X-ray method to look inside the rocks to see how much water and gas was there. The reason these rocks can float is because of something called surface tension, which is like a very thin, the size of a human hair, layer of air on the water's surface. This helps some animals, like lizards and insects, to really walk on water. And these floating rocks are not just cool because they travel, but also because they can actually help scientists find underwater volcano eruptions. They can also carry living things across oceans since they tend to collect some plants and other things rich in nutrients. So it's basically like a free cruise, until you sink down at some random spot. No iceberg needed. Here you have floating rocks. And in Death Valley in California, there's a strange phenomenon where big rocks move across a dry lake bed and leave trails behind them. People wondered how this was possible for 60 years until the case was solved. Some thought there must be strong winds moving these rocks, or maybe even ice. But scientists found these winds aren't really strong enough to move such big boulders. They placed cameras on cliffs near the rocks, even though they were hard to reach. They did this for 3 winters in a row to study the temperature, rain, and wind in the area. Their idea was that ice might lift the rocks and let the wind push them. To test this properly, they put a rock in a container with water and sand and froze it. When they later pushed the container, the rock moved like it was on ice. This experiment helped prove their theory. And what's interesting is that the rocky area in Death Valley is similar to one of Saturn's moons, Titan. So these weird things on our planet may help us understand other phenomena, even in space. The reverse waterfall in England is an example of a spot with weird gravity too. You can find it not far from Hayfield. It has water that looks more like a fountain than a waterfall, considering it goes up toward the sky. But it turns out gravity doesn't have anything to do here. It's just the wind. It's so strong that when the water falls down, it catches it and pushes it back up. But where does this constantly strong wind come from? You can see a similar thing at Hoover Dam in Nevada, US. Try to climb up the dam, 726.4 feet, and pour some water out of a bottle. Not working? Yep, the water won't flow down as it normally would. It will fly up. You'll have the same result if you throw some light object from the same height. You will get it back. And this happens because of the strong airflow too. So these things seem like gravity is messing up with us. But there's always a logical answer behind that. Hopefully, we'll get one for the gravity hole in the Indian Ocean too.
Going to the beach in winter seems like a good plan. You can have a bonfire, build a sandcastle, search for shells, or swim in the ocean. The vibe might make you overlook the dangers ahead of you. Do you really think through the potential risks of paying a visit to the beach in the winter? The number one risk is waves. You might think it's okay to admire the view on the beach a few steps back from the ocean. Now let me introduce you to sneakers. Not the chocolate bar, sneaker, or with another name, sleeper waves. These are oversized coastal waves. They catch people off guard because they occur without warning or trace. These waves are particularly seen in Oregon, United States. People have been injured and at least 17 people have been swept up into the ocean since 2000. It got more media attention in 2011 when a memorial statue was built honoring the 2 teens faced with sneaker waves in Oregon. So, how come these waves are so dangerous? It's about their nature. They come out of the blue. With big waves, you see them coming or growing big. Plus, they form in the ocean and come towards the beach. These waves appear near the shore. It leaves less time for you to run to a safer spot. Okay, most of the time, they're not huge, as would be seen in apocalyptic movies. Yet, you can never know what nature holds. Maybe you remember this example from Mavericks. In 2010, a crowd was watching the surfing competition. Suddenly, 2 large waves struck the people on the beach. It broke the seawall and injured more than 10 people. Sneaker waves don't look particularly larger than other waves until they break and quickly reach the beach. They form in a period of 10 to 20 minutes in between soft and regular-sized waves. They can surge more than 150 feet beyond the foam line. Then they reach the land with high power. Plus, they carry lots of sand and gravel with them. Sleeper waves are more commonly seen along steep coastlines compared to beaches with wider and softly sloped areas. People named these waves, not scientists. They observed what waves do. They washed up in a sneaky way. I mean, scientists didn't classify this phenomenon as a distinct sort of wave like they did with tsunamis or rogue waves. There's little scientific research made about them. Researchers say that sneaker waves form in offshore storms. These storms transfer the wind energy to the water surface. The waves carry this energy and then arrive at the beach during times of calm weather. The larger amount of energy they obtain compared to the regular waves that preceded them causes them to go higher up the coast. Imagine you go for a walk on the beach with your dog. The waves gently reach the beach. You play the throw and catch game. You don't know about sneaky waves, so you turn into an unwary beachgoer. What's the risk? Being washed into the water trapped against rocks. Since it's winter, you tend to wear heavier clothes. The sand that sneaker waves carry can quickly fill clothing and shoes, and that weighs you down. How can people enjoy the beach safely? First off, keep your distance if you're on the beach for storm watching, for instance. It might be mesmerizing to see how waves roll in over miles of ocean. The storms hit the shore, and you look at those extreme turbulent swells transform into strong 30-foot-long waves. Finding a higher spot that sees the ocean and waves might be best. Be the eagle, not the crab. Did Confucius say that? The second tip is if you're determined to storm watch, never turn your back to the ocean. Yes, eyes on the water. Lastly, be mindful of which part of the beach you're walking on. Stay away from the logs because they hold water. The water increases their weight. In the worst-case scenario, the ocean is powerful enough to roll the logs onto you. Let's assume you're hiking near the ocean. Use the designated trails because park authorities determine them as the safest roads possible. Going off-route can sound charming, but it can be dangerous for you and harmful to the ecosystem in the surrounding area. Now that you know where to walk, you can keep your eyes open about the geological stuff. Like the rocks can be slippery, erosion can rip them off. Yeah, it's better to avoid walking near bases of cliffs and bluffs. You'll never know when a natural phenomenon will occur. It might sound a little extreme, but you may want to check the tsunami evacuation routes of the area you're visiting. Tsunamis are hard to predict, but tides aren't. Tide tables are available online. This natural phenomenon looks harmless, yet it can isolate rocks from headlands and the shore. You probably don't want to find yourself with soaked wet clothes in the ocean for no reason. Climbing up onto the logs might not be the best idea either. Sure, they look heavy and sturdy when you're climbing, but even the smallest wave can take you like a leaf flying in the air. Not just logs, but also jetties are tricky. Sudden waves can make you lose your balance, and you can collapse. Let's return to the scenario where you and your dog are walking on the beach. This time your pet sees shorebirds and chases them. Birds could be there for foraging or roosting. Your dog could interrupt their chill zone. They can lose their energy reserves. Can you bump into creatures hiding under the sand? Some sorts of creatures can be dangerous for you. Better not to poke someone's home. Take a look at this one. It's a horseshoe crab. This one looks scary, yeah, but it's safe as long as you don't step on its spines. So it depends on the type of creature you see, but generally, it's okay to explore the sand with caution. Until now, we look at scenarios where you were on the beach when they caught up to sneaker waves. You could be in the water too. You could be surfing, just like the contestant in the Maverick surf competition, or swimming, if swimming is the new case. Consider these. The temperature is lower, the waves are crazier, and there are probably no lifeguards there watching you in the winter. Swimming with friends is a safe option. Bonus, it's more fun. You should choose your swimming location carefully. Are there dangerous rocky areas? Can you easily go out if there's some sort of emergency? Know your spot. For that, you should check the weather too. Planning has a key role in winter water safety. a quick weather forecast and sea conditions check would do. You can consider buying a tow float if you're an adventurous open water swimmer. It's a flotation device designed to increase the swimmer's visibility in the water. They are lightweight and have fluorescent colors. Alternatively, you can wear a brightly colored swimming cap. We can talk more about the gear. Wearing a wetsuit is wise, as well as wetsuit gloves and boots. You can put your phone in a waterproof pouch or bag. Staying warm is essential in the winter. Don't just jump into the water at once. This can result in cold water shock. It's vital to enter the water slowly. In that way, your body can get used to the temperature. Once you take all the necessary precautions, you can enjoy the beach and explore its offers. What sort of gems can you find on the beach? A mermaid's purse? Maybe. No, it's not the purse of Ariel from Disney's Little Mermaid. That's actually an egg case belonging to sharks and rays. It's made out of keratin, kinda similar to your hair and fingernails. These purses are the place where the embryo grows. The egg hatches and the cases are carried away with the water to the beach. If you want to find one, you can look at the area near the seaweed. Have fun while searching for it! Now, I'm ending this video with a quick joke that's suitable for the cold weather of winter. What did the ocean say to the beach? Nothing. It just waved.
Okay, let's try something together. Open any world map you have available. It can be the one you find in your bookcase or even an online version. Take a look at the vast area covered by water. That's 71% of the Earth's surface. And all of that is salt water from the world's oceans. There aren't any borders between the four oceans we've all come to know, but oceanographers and the world's countries did traditionally split these waters into four distinct regions: the Pacific, Atlantic, Indian, and Arctic Oceans. And here comes the big surprise. The scientific community has recently recognized the fifth body of water. It's called the Southern Ocean, and three of the four original oceans border it. It circumnavigates Antarctica and the lower portion of the globe and reaches Australia and the southern portions of Africa and South America. What makes this ocean so special? How did the scientific community eventually recognize it? And more importantly, what mysterious creatures does it hide? Let's find out. The Antarctic Ocean, or the Southern Ocean, was first mentioned back in 1937 in the second edition of the International Hydrographic Organization's Limits of Oceans and Seas. That's a mouthful. Back then, this organization considered that it was wrong to consider the Antarctic Ocean as its own distinct body of water. Why? Well, because at that time, an ocean was defined as water surrounded by land, and not water surrounding land. However, they reconsidered it in 2000 and voted to include this ocean in the official list. They also decided on the name Southern Ocean over the commonly used Antarctic Ocean. Finally, the organization concluded that the ocean should be considered as ending at the 60th parallel south latitude. But how old is this ocean? Well, many specialists believe it to have formed only 30 million years ago, which would make it the youngest of the world's oceans. It was created when Antarctica and South America moved away from each other during the early stages of our planet's development. This unique water current is a distinctive component of the Southern Ocean, as it helps keep the waters flowing around the icy continent. It's called the Antarctic Circumpolar Current, and it moves to the east with incredible speed. It's estimated that it moves an enormous amount of water per second. Some of the disputes regarding the Southern Ocean also have to do with this amazing current. Some specialists believe it separates the water of the Southern Ocean from the waters of the nearing Atlantic or Pacific. Only the rapid circulating water is considered the Southern Ocean. On the other hand, though, a handful of scientists say that the current actually makes the naming issue more complex by not limiting the waters to a specific geographic location. They believe that the waters in the current are different in terms of composition from waters in the northern oceans because they are way colder and have a lot more salt. Sailors don't really like this new body of water, mostly because of the frequent cyclone-like storms that it experiences. They happen because of the big temperature difference between the ice packs and the ocean waves. As a result, these storms are very difficult to surpass for any sailors that happen to encounter them. I mean, really, these are the strongest winds found anywhere on our planet. More so, the vessels going through this area must also be wary of the frequent icebergs that may pop up every now and then, and also of the low surface temperatures. Just to paint you a better picture, some of the icebergs found here can span over several hundred meters and can exist all year round, regardless of the season. The latitudes from 50 to 70 have even earned the nicknames of Furious 50s or the Shrieking 60s because of these intense year-round storms. Even the landscape is unique. They say the Southern Ocean has bluer glaciers, colder air, and more intimidating mountains than anywhere else in the world. Now, let's get to the mysterious creatures that call this place home, as thousands of species of wildlife live only here and nowhere else in the world. Let's start with the quirky sea pig, or one of the sea cucumbers as it's sometimes called. There are a lot of them in the waters off Antarctica. Why is it called that way, though? Because of its pink hue and round, bloated looks. On a closer look, it even appears to have a little tail and set of ears, just like a pig. They do help a lot with the quality of the waters here, filtering sand and sediment. Then there are the Hoff crabs that live on the floor of the Antarctic Sea. The Southern Ocean is a cold water environment, but crabs are more adapted to warmer waters. So, Hoff crabs gather around the warmth made by volcanic vents. They get the needed warmth and food here. You can find them in large piles, one on top of another, literally filling the space of the vent openings. Now, wonder how they got their unofficial name? Well, it's because of their apparent similarity to the actor David Hasselhoff, whose impressive chest reminded explorers of the crab. Okay. Ever seen a fish that's completely transparent? You'd have to get to these waters down in the south, but they do exist, and they are simply called the ice fish. You can basically see inside them, being completely clear and all. That's because of their see-through skin and because they don't have any red blood cells. Their special power is that they can use antifreeze to prevent their bodies from going solid in the cold waters of the Southern Ocean. Instead of the standard thicker blood, the red one with hemoglobin, ice fish have thinner blood that moves around more easily throughout their bodies, hence giving them the much-needed nutrients and oxygen. Now, is there a monster hidden in these waters? Some people believe this to be the case, and thanks to recent research, we even have video footage of it. Some Australian researchers stumbled upon a bunch of weird-looking creatures that were swimming near the seafloor of the Southern Ocean. This pink blob-like fish seemed to be propelled by a little pair of fins. To quote them on it, it seemed to resemble a chicken just before you put it in the oven. I'm not sure I even want to know what that looks like. It took them some time and research to identify the monster. It's a shy species of sea cucumber, known more by its creative nickname, the headless chicken monster. We've known this creature has existed since the late 1800s, but we've barely ever seen it. And we've only ever captured it on tape once before when it was spotted in the Gulf of Mexico, which is quite far from the waters off the coast of East Antarctica. There's so much we don't know about this creature, like how many of them exist in our waters and how they live, eat, and reproduce. Ever heard of the emperor penguin? It's not a penguin species that just happens to have a crown on its head, if that's what you're thinking. But they are one of those penguins that inhabit this specific location and are also the largest species of their kind altogether. What makes them special is that they make their colonies on the sea ice, and most of them never step foot on land. More so, penguin dads lose almost half their weight while incubating the eggs. They're also fascinating swimmers, able to dive deeper and longer than any other bird, up to 700 feet. Not to mention they can stay submerged for up to 18 minutes at a time as they gather food. We have yet to uncover all the secrets of the mysterious Southern Ocean, but it's clear that it's home to some unique and fragile marine ecosystems. Recognizing it as a new ocean could be one way to focus the public attention on it and help its conservation.
The Empire State Building's tower was designed to serve as a docking station for dirigibles. At that time, people believed that these airships would become the main means of transportation in the future. The project included gangplanks, check-in and customs offices, and so on. But then the engineers realized that the wind up there was too strong for their plans, and they gave up on their idea. Angel Falls, the largest uninterrupted waterfall on the planet, is more than twice as tall as the Empire State Building. During the dry season, the falling water sometimes evaporates before it reaches the ground. One of the most mysterious sounds ever heard on Earth was the bloop. It occurred in 1997 and resembled the noise of marine animals, but the volume was too great for a sound produced by a living creature. The bloop continued for 1 minute. It started from a low rumble and then rose in frequency. Antarctica might just look like a giant field of ice, but there's actually a huge continent underneath. That means that it has volcanoes, mountains, and valleys, like any other continent. Scientists have recently discovered that the Antarctic landmass has the lowest point on the planet, as well as huge mountain ranges. If any of the numerous volcanoes were to erupt, it would melt a huge part of the surface ice and increase the spill of ice into the ocean. The sea level would rise and flood coastal areas around the world. The ocean waters would also be disrupted, putting marine life at risk, though all of these volcanoes are dormant at the moment. Each day on the South Pole lasts 6 months on this continent. The South Pole only has a single sunset and sunrise across an entire year. Early Earth might have been purple, not green. There's a theory that ancient microbes used molecules rather than chlorophyll to absorb sunlight. These molecules likely gave living organisms a violet tint. During the Stone Age, the entire population of Central Europe was around 1,500 people, which means they would all fit on a mid-sized cruise liner these days. Astronomers have figured out that the Milky Way weighs around 1.5 trillion solar masses, and one solar mass is the mass of our Sun. A tiny part of this weight is a supermassive black hole at the center of the galaxy, and 200 billion stars. The rest is dark matter, mysterious and invisible. If all sheets of Arctic ice and glaciers melted at the same time, the sea level would rise for the height of a 26-story building. Under black or UV light, ripening bananas look bright blue. That's because of the chlorophyll that's breaking down when the fruit is ripening. Because of tectonic plate movements, the Pacific Ocean shrinks every year, and the Atlantic Ocean gets bigger by the same amount. These days, there are only 2 ice sheets in the world left after the planet's last ice age. The first is the Greenland ice sheet. The second, the Antarctic ice sheet, is enormous. It's the size of Mexico and the continental US combined. Tsunami waves often go unnoticed. They don't rise for more than several inches above the surface until they reach shallow waters. When the ocean is deep, though, they can travel as fast as a long-distance passenger airplane. Corals that live in shallow waters produce their own protection from the sun. Without it, sunlight would harm the algae living inside them. To protect these algae, which are the main source of food for the corals, they fluoresce. This process makes proteins that act as sunscreen. Almost 90% of the volcanic activity on Earth happens in the oceans. The South Pacific has the largest concentration of volcanoes people know about. There's one volcano cluster that has 1,133 volcanic cones. All of them are active and cooped up in an area the size of New York State. The Zemchug Canyon in the middle of the Bering Sea is the largest underwater canyon ever discovered. There are more treasures and artifacts at the bottom of the ocean than in all museums in the world combined. In 1900, one of the biggest hurricanes struck near Central America and in the Gulf of Mexico. It then went as far as Florida and Texas and is considered to be the most devastating hurricane in the United States history. They first detected it on August 27th, and it lasted for many days. By the time it reached the Texas coast, the storm had turned into a Category 4 hurricane. Hurricanes are categorized on wind speed and intensity using something called a Saffir-Simpson scale. There are 5 different categories from 1 to 5, with 1 being the weakest and 5 being the strongest. The people of Galveston had less than 4 days to prepare for the arriving storm that even stretched out to Oklahoma and Kansas. The Great Hurricane then made its way to the Great Plains and turned towards the Great Lakes, New England, and reached southeastern Canada. The storm was so bad that more than 3,600 homes were damaged, even though they were sturdy enough to withstand the storm. Given the population numbers back then, it was equivalent to hundreds of thousands of houses destroyed, if not millions. Spotted Lake, Canada. They call it the most magical spot in Canada. In winter and spring, this is just a regular lake that looks like any other, but try going there in the summer when the water starts to evaporate. It'll feel as if you've entered a different world, a polka-dotted landscape with blue, green, and yellow spots. Over the summer, there are over 300 pools there, and they all look magical. Over the centuries, people believed each of them had different healing properties. Oh, and the explanation for the vibrant colors is pure science. Each of them has a high concentration of different minerals. We live inside the sun. Its atmosphere stretches far beyond its visible surface, and even though Earth is 93 million miles away from the star, it's still within reach of the sun's atmosphere. Auroras happen when charged particles from the sun get caught by Earth's magnetic field and crash into the upper atmosphere near the poles. Our planet is gradually slowing down the speed of its rotation. It happens at an unhurried pace of 17 milliseconds per 100 years. Because of this, our days are becoming longer, and still, only after 140 million years, a day on Earth will last 25 hours. Earth's southernmost continent, Antarctica, is only the fifth largest one, but it contains almost 70% of the planet's fresh water and 90% of the world's ice. Antarctica is also considered to be a desert. Lots of rocks on Earth have a Martian origin. Scientists analyze the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. It turned out that these rocks had arrived from the Red Planet. The largest sandcastle in the world is located in Denmark. 30 sand sculptors who created it used more than 5,000 tons of sand. To make it more durable, they added 10% of clay, together with a layer of glue. They built it to stand tall against long and stormy winters. Some photons that don't get absorbed are re-emitted, and their wavelength determines the color we see. When you expose a material to sunlight or photons of higher energy, it can damage its chromophores, which is why they won't be able to emit photons at certain wavelengths. Red materials fade in sunlight the most. Their chromophores emit red light in a way they mop up photons of the rest of the wavelengths. From 60 to 100 tons of space dust drift down to our planet's surface every day. These tiny cosmic particles are mostly released by comets, which are usually made of dust and ice. When the sun turns this ice into vapor, the remaining dust travels down to Earth.
In the past 30 years, scientists have made an incredible discovery of a new creature living deep beneath the surface of the ocean, and the name of the creature is the harp sponge. Now, if you're wondering why it took so long to come across this animal, then I might have the answer. These creatures typically hang out at a depth of roughly 11,100 feet beneath the ocean's waves. This sponge species was first discovered off the coast of California thanks to a robot that was sturdy enough to explore those crazy depths the ocean has to offer. This is no doubt an area of the planet where even the most benign-looking creatures can be potentially dangerous. But even scientists were surprised to find that this creature was more than just a sponge. Now, this might seem obvious, but the harp sponge got its name because its basic structure, referred to as a vein, is the same shape as a harp. Each vein is made up of a horizontal branch supporting several parallel vertical branches. But don't let the harp sponge's fanciful and amusing appearance or its non-intimidating name fool you. Yeah, the harp sponge is very much a deep-sea hunter. It has a unique ability to capture and envelop small animals using its rhizoids, short, thin fibers. With their help, the harp sponge clings on to the soft, muddy bottom and catches tiny creatures that get swept into its branches by deep-sea currents. Uh-oh. Other sponge creatures often feed by pulling bacteria and bits of organic matter from the seawater and filtering them through their bodies. But not our harp sponge. Instead, it snatches its future meal with minuscule barbed hooks that cover each of the harp sponge's branches. Now, harp sponges prefer tiny crustaceans like crabs, crayfish, shrimps, and prawns. Once the harp sponge has one of them in its clutches, it envelops the animal in a thin membrane before slowly beginning to digest it. So, pal, what's eating you? Oh, Harpo? Too bad. Researchers believe that harp sponges use this method of feeding because there aren't enough nutrients that deep down. This makes traditional filter feeding less effective. Research has shown that the creature is still in the process of evolving. Early harp sponges researchers found only had 2 veins, but later scientists discovered other harp sponges that had 6 veins. The harp sponge might have evolved this elaborate candle holder-like structure to increase its surface area. In general, harp sponges typically grow up to a length of 1 foot, but researchers have seen a creature that was 2 feet in length. The harp sponge is not only very unusual, but also beautiful to look at. See those tiny white balls on top of the branches? Now, why don't we look at some other creatures that live below the photic zone of Earth's oceans? The photic zone means the area beneath the ocean's surface that still receives some sunlight. Thanks to this, there are loads of different creatures and organisms living there. Any animal living beyond this layer qualifies as a deep-sea creature. The Tomopterus worm is a segmented worm you can find in the twilight zone of the ocean. This is the area that lies between 650 and 3,300 feet beneath the surface. These creatures are often no more than 1 inch long, but the largest of them can grow up to 1 foot. While swimming around and feeding, these worms do what researchers describe as an amazing smooth dance. That's because the creatures can swim extremely quickly and maneuver at tight angles with ease. Now, I know most people hear the word worm and think of the common earthworm, so it's quite interesting to know there's a deep-sea worm out there that never leaves the water during its entire life. Similarly, most of us try to avoid jellyfish that either rest on the sand or sit on top of the ocean waves. This isn't the case with a chrysota jelly. That's a deep-sea creature too. This beautiful jellyfish is mostly ruby red, bright orange, or electric purple. That's what helped researchers realize they had found a new species of jellyfish. The creature grows to a maximum size of 1 inch across. It has tentacles that stretch out in every direction. Now, if you come close to this jellyfish, it'll pull all these tentacles in toward its body before rapidly swimming away to avoid danger. Yes, you are dangerous. The chrysota jelly is extremely rare. You won't see it very often. You might need to borrow that deep-sea diving robot I mentioned earlier. While worms and jellyfish might seem quite harmless, this isn't the case with the Pacific viperfish. Ooh. This creature is equipped with a noticeably big mouth, like me, and the needle-like teeth inside are key to its hunting strategy. Pacific viperfish live at around 5,000 feet below the ocean surface, but they're among those numerous marine animals that migrate each night from the ocean depths toward shallower waters to dine. What's on the menu for dinner tonight? Lots of small fish and shrimp. The creature can grow up to 12 inches in length. Its 2 front fangs, which stick up from the fish's bottom jaw past its own eyes, are especially dramatic. When the fish unhinges its jaw, its mouth can open wide enough to engulf smaller animals, and the teeth form a cage to prevent an escape. Now, have you ever seen an underwater creature that looks like a strawberry? Trust me, it does exist. Just look at these dots on the strawberry squid. The creature has a big eye and a smaller one. You might think this unconventional pairing would be awkward and uncomfortable, but it's actually the opposite. The big left eye looks upward. It spots shadows cast by other animals in the dimly lit waters above. The eye's tubular shape helps it collect as much light as possible. On the other side of the squid's head, you can see its right eye. It's small and looks downward. This eye searches for flashes of bioluminescence produced by animals lurking in the darker waters below. Now, bioluminescence means the production and emission of light by living organisms. By the way, the squid has a nickname. And no, it's not Squiggy, although that's a great one. It's known as the cockeyed squid. This is simply due to the remarkable difference in size between its 2 eyes. I think I like Squiggy better. And so it goes. Since light doesn't reach the deep sea, the strawberry squid's body actually looks black. This helps the creature hide from enemies, such as sharks and dolphins. In general, the strawberry squid grows to a length of 5 inches. It typically lives around 3,000 feet below the surface, but floats to shallower waters at night. Now, the feather star is a marine creature without a backbone, but with feather-like arms that radiate from the center of its body. These creatures first appeared around 200 million years ago. Related to sea stars, they look like a flower, but if you approach them, they'll quickly swim away. But not all feather stars can swim. Many species can only crawl along the bottom of the seafloor. Like some of the other deep-sea creatures we've looked at, the feather star can adapt to its surroundings. It has a creepy ability to shed its arms, the same way some lizards can shed their tails. This also helps them escape from their enemies. Feather stars live all across the globe, from the equator to the poles, from the shallow waters on top of reefs to the deep, deep sea. Now, given that we're dealing with mysterious creatures, the name of this one is quite fitting. The swift vampire squid should be the official symbol of life in the deep sea. The animal has a dark red body, huge blue eyes, and a cloak-like web that stretches between its 8 arms. This, along with its name, may suggest that the creature is some form of a terrifying hunter. In reality, though, the vampire squid is a soft-bodied, timid creature, about the size, shape, and color of a football. It grows to roughly 12 inches in length and lives 3,000 feet below the waves. There's almost no oxygen there, but also relatively few predators. Whew, I think I'll need to decompress from this one. The ocean is one of the most incredible places on Earth. It's not only beautiful, but also dangerous. We all know about sharks, huge octopuses, heavy storms, and the Bermuda Triangle. But there's something more terrifying and more dangerous than all of these things. I'm talking about rogue waves. The 4-passenger yacht Mignonette is sailing through the Cape of Good Hope in southern Africa. A storm blows through, but the yacht successfully survives it. By evening, the wind has completely subsided. The sea is calm. The team, tired after the storm, is going to rest. At this moment, seemingly out of nowhere, a 39-foot wave appears and crashes over the yacht with terrifying force. The yacht succumbs and sinks. Thankfully, the passengers escape in a lifeboat. For the next 24 days, they drift on the open sea until they're picked up by a passing ship. No one believed the stories of the surviving passengers about a huge wave. This story isn't a plot from a thriller movie, but a real event that occurred on July 5, 1884. Now imagine that you're sailing on a modern yacht in the open sea. The sun is shining brightly. There's not a single cloud. The sea is crystal clear and calm. What could be better than a vacation like this? Suddenly, you hear a very loud hum. In 2 to 3 seconds, a huge 33-foot wave appears from the calm surface of the sea and crashes into your yacht. Fortunately, the ship manages to stay afloat, and the wave disappears as suddenly as it appeared. This is also a real case that happened to the owner of the Calaran yacht on June 17, 2018. These waves have different names: white, rogue, wandering, monster. The French call them a bad joke. Unfortunately, there's nothing to laugh at. A meeting with such a wave usually ends with a sunken ship. Sirens, sea monsters, the anger of Poseidon. This is how people explain the appearance of massive waves in ancient times. Christopher Columbus was the first to write a note about a rogue wave as a natural phenomenon. In August 1498, his team explored the shores of West India, later America, when suddenly all of the crew members heard a deafening roar, and then a towering 88-foot wave appeared out of nowhere. Fortunately, the wave passed by, and Columbus went on his way. After that, a lot of reports were recorded about this phenomenon, but no one believed the sailors. Mermaids, kraken, and now monster waves? Come on, guys! This is the typical reaction to anyone claiming to have witnessed the nightmarish waves. Even when a 74-foot rogue wave suddenly fell on the British liner Queen Mary in 1942, the 15,000 people who lived to tell the tale were rarely taken seriously. Only in 1995 was the rogue wave officially recorded with special instruments. That day, an 85-foot wave hit the Norwegian gas platform Doppner. In order to study the nature of these waves, in 2000, the European Union created an international project called Max Wave. As part of this project, scientists launched 2 satellites to monitor the world's oceans. However, they ended up with more questions than answers. There's a special wave theory, according to which the larger the wave, the less likely it is to occur. Max Wave satellites managed to record waves up to 82 feet. But here's the most interesting part. Such a wave should only appear every 200 years. But satellites discovered 10 monster waves in the first 3 weeks of operation. 19 years have passed since then, and we still know very little about it. The worst thing is that scientists have no ideas about how to predict the appearance of these waves in advance. Modern radars and sonars have recorded the proportions of these waves. Their height reaches from 39 to 164 feet. Their speed can reach 62 miles per hour, and their life expectancy is from 20 seconds to 2 minutes. Although information is scarce, scientists have managed to divide these waves into 3 types. The first type is the classic white wave. It appears not only in a storm, but also in a calm sea. After an unexpected appearance, it also suddenly dissolves into the water and leaves no residue. The second type is Three Sisters, and you guessed it, these are 3 consecutive waves, one of which is more massive than the others. Even a huge supertanker could break under the weight if caught in such waves. The third type is Wave Monster. Of all 3 types, this wave is the most dangerous and unpredictable. Imagine a 15-story building. The spectacle is certainly amazing, but I wouldn't want to see it in real life. Anyway, you can watch a lot of videos with rogue waves on YouTube, but after you watch our video. But what provokes these lonely waves? No one knows for sure. Perhaps rogue waves are of the same nature as tsunamis? Well, not at all. Tsunamis occur as a result of underwater earthquakes and grow as they draw closer to the coast. Some believe that they appear when the surface sea current encounters a strong headwind. Others are sure that the waves are born from the collision of warm and cold currents. Still others are convinced that it happens because of gravitational anomalies, when gravity sharply decreases or increases. There's also the theory of wave interference, small waves combining to form one big one, just like a snowball. But the most interesting theory is that waves form due to kinetic vampirism. Insert Dracula joke here. According to this version, under certain natural conditions, waves acquire the ability to exchange kinetic energy. And among all the waves, there will be one vampire wave, which will absorb the energy of the others. After accumulating enough energy, the vampire wave splashes it out. This theory explains the impact force and its sudden disappearance. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the most mysterious place in the Atlantic Ocean, the Bermuda Triangle. And while it's likely that rogue waves periodically appear there, it's impossible to consider them the main solution to the mysteries of the triangle. Besides ships, planes disappear there, and it's unlikely that the waves can reach them. Adding even more mystery to the phenomenon, these waves appear not only in the seas and oceans, but also in lakes. They were recorded numerous times in the Great Lakes. In Lake Superior, the largest of all the Great Lakes, the appearance of the Three Sisters has been recorded several times. In addition to rogue waves, sailors have told about a more terrible phenomenon, sea hollows. Imagine that this is a very big wave, but just the opposite. It goes under the water, forming a large dip in the sea. But unlike waves, such hollows have never been officially recorded. Rogue waves can be dangerous in a similar way by forming sea holes in the water. When the wave builds up, It draws in all the water around it, so near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. I think the Jaws movie should be replaced by a new film, Waves. Who cares about sharks now, when at any moment a wave the size of a skyscraper could come rushing towards you? Hey, anybody remember the movie The Poseidon Adventure? That was a rogue wave that capsized the ocean liner. There are no ways to anticipate rogue waves, but you can significantly reduce the risk of meeting one. Study the history and meteorological records of the area you want to visit. Most often, rogue waves are found off the east coast of Africa in the Indian Ocean and in the North Atlantic. By the way, it was there in 1985 at the Fastnet Rock Lighthouse that the highest wave ever recorded was captured. Its height reached 157 feet. If rogue waves don't scare you and you're determined to set sail, then watch for weather changes and, most importantly, look often at the horizon. Single waves can appear in the distance, so you have a chance to evade them. And if one narrowly misses sinking your boat, well, as it goes by, be sure to wave. Ooh, you're diving into the dark and icy waters of Antarctica. The eerie blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well. Off the western coast of Australia and near New Zealand, they recorded similar but higher pitch signals, which they named bio-goose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on bioduck and biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The biogoose sounds from the waters off Australia and New Zealand likely belong to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a "hey" of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike bioduct, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping, reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales, specifically Bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of Bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound's source was a giant sea monster, kraken, or some other creature. The hype around the bloop didn't last very long. Scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. How about we end this video with a mystery that still baffles scientists? Meet upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.